In this video, I introduce a frozen model for multimodal few-shot learning. When auto-regressive language model is trained at a sufficient scale, it's able to learn a new language task after being propagated with just a few examples. As shown here, this auto-regressive language model. Frozen model can transfer the few-shot learning ability to vision and language multimodal setting. There's a vision input and this language input. Using a land image and caption examples, frozen model trains a vision encoder, as shown here, to represent each image as a sequence of continuous embeddings, such that a pre-trained language model propagated with the prefix generates the appropriate caption or answers the question as shown here. The prefix-turned model is a multimodal few-shot learner with the ability to learn a variety of new tasks when conditioned on examples, represented as a sequence of multiple interleaved image and text embeddings. A pre-trained auto-regressive language model, Alpha-Theta, is based on the transformer architecture. Self-supervised learning trains auto-regressive language model to maximize the log likelihood of our next word, defined as here and shown here. Where Y1 to L is a sequence of tokens produced by tokenizer from input Y. And TL is a continuous embedding generated by function G theta, which is used to input to the transformer. Vision encoder V5 takes a raw image as an input to emit a continuous sequence as an input to the transformer. The sequence of continuous embeddings produced by vision encoder V5 is linearly projected to the same dimensionality as the token embedding TL, namely I and D have the same dimensionality. The visual prefix together with the text embedding is fed into the transformer encoder. During training, frozen model updates only the parameters phi of the vision encoder V5 using the paired image caption training example, as shown here. While freezing the transformer language model alpha theta and the text embedder G theta, as shown here. Frozen model treats captioning as a conditional generation of a caption text Y in given image X. The input image X is embedded as I1 to IN, and the vision encoder is trained by maximizing the log likelihood defined here and shown here. Whilst the parameters theta are frozen, and each element IQ of the visual prefix receives gradients for optimization with backpropagation and stochastic gradient descent. The visual prefix during training is viewed as the partial embedding of multimodal input to predict the output of a frozen model. For more details, please check with these references. Thank you. Bye.